Welcome to the 24th International Conference on Competition and Mathematical Methods in Science and Engineering. My name is Oscar Truy, and on behalf of Juan Carlos García Díaz and Ángel Peiro Signes, I'm going to present you the following communication called Hybrids Multiple Seasonal Hold Binters using Pattern Sequence Forecasting for Discrete Interval Moving Seasonalities Forecasting Method applied to forecast all electricity demand. You will notice the names are long and therefore have been abbreviated. We all belong to Universitat Politécnica de Valencia. This is the Polytechnic University in Valencia, Spain. Juan Carlos and I belong to the Statistics Department, while Ángel belongs to the Management Department. We expect you to find interest on this work. Contents of today are the following. First, you will see a brief introduction. Secondly, we will explain the methodology. And finally, we will show you the results we obtained as well as the conclusions we have reached. But first, the main question is, why is important in the forecast? In this slide, you will see three different pictures. In the center, representing the transmission system operator, that from now on this will be abbreviated as TSO. They are responsible for the distribution of electricity in Western countries. Due to this responsibility, they need to settle what is going to be produced every hour, every minute, every day, according to what is expected to be consumed. On the left side of the picture, the producers are waiting for operational planning to assign the production units how much energy they need to deliver. The customer, on the right side, they only want to demand electricity and not taking care about where they are produced. And they want to pay for this energy as little as possible. So, just in the middle lay the TSOs. The function is to forecast what customers are going to demand in the following hours, days, as said, and settle this information to all entities. But this is not all important in terms of service, but also to settle the price. Assumptions of the TSO will be used to bid the selling and buying prices of the energy. But remember, energy cannot be stored easily in big quantities. Thus, if there is too much energy, it must be wasted, and if is there less energy as demanded, for sure someone is going to claim. So the mismatch between the forecasted against what is really demanded will produce huge losses. This is why it is so important, the accuracy on electricity forecasts. Any method the TSO can use to produce forecasts, as machine learning, even deep machine learning, statistical methods, functional or whatever, will need to have a time series approach. Let's analyze the features of the typical time series for electricity demand. On the right side, you have the hourly electricity demand in some weeks for a Western country. The seasonal component is easily detected, and two different seasonal patterns can be seen. One for the intraday cycles and another for the interweek cycles. If the dataset is extended in time, it is also easy to detect another seasonal pattern called intra-year. The more extension of the time series you may do, the more seasonal patterns or cycles you could find. The most important is that this kind of series have a very determinate seasonal pattern that allows models like whole winters to be really interesting to be used for making forecasts. All time series methods use the observed data in the past to train or to fit a model that will be used to produce forecasts in the future. They try to reproduce the past and they will predict the future. In a regular way, it works. However, this analysis must always deal with irregularities in the time series. It could happen, due to different circumstances, that the series do not follow the same pattern. We located two main reasons. The first one is the weather and climate conditions, and when we are talking about this, we are just saying the extreme conditions. But maybe the main reason why the series could have irregularities are special events, calendar events. These are holidays, breaches, strikes, whatever you can imagine. Is there also, as you can see here, for instance, in the picture at the right side. The model, if it does not modify the behavior of the forecast, will try to reproduce previous observed data, but then the special event is coming and the final result is not what expected. The red dashed line is what the model has forecasted, whilst the black one is the real demanded. Then there are many ways to deal with these irregularities. Could be, for instance, using dummy variables to split the original model in various. It could be just modifying the original time series. But in the past, we developed the multiple seasonal whole winters using discrete interval moving seasonalities models that improve results compared to the other methodologies. The advantage of using this method was that the special event was modeled as a new seasonality within the model, not modifying the original one. In this case, there is a new proposal, and this is the novelty of this work. We are going to use artificial intelligence. In fact, we are going to use clustering techniques like pattern sequence forecasting to deal with these spatial events. The discrete seasonalities will be obtained using the pattern sequence forecasting, and that gives the name to this methodology. Let's start with the methodology. First, we want to see what are the multiple seasonal whole winters models. As you can see, they are based on the exponential smoothing of the observed data. So that means it is a numerical analysis in which, through the use of a smoothing parameter with values between 0 and 1, the equations are going to filter the data, providing a higher value to this parameter to give more importance to the newly obtained data, and lower values to give more importance to all the data. These parameters you can see here are alpha, gamma, and deltas. There are the following smoothing equations. The first one is for the level, the second is for the trend, and the third is for the seasonalities. We remind you that there will be as many seasonal smoothing equations as seasonalities you consider. The information of all these equations is gathered by the last forecasting equation that will produce key ahead forecast. Another aspect of the method is that the combination of equations can be done in an additive or multiplicative way. In this case, we show you the additive method for the trend and the multiplicative method for the seasonalities. This is the most commonly used. To fit the model, one step ahead forecasts are produced and compared to the observing data, providing values to the smoothing parameters and all at the same time. The error produced is measured and using a minimizing algorithm, these smoothing parameters are going to be obtained. To deal with spatial events, we need to bear in mind that they only occur on these spatial days. Only on these days and not during the rest of the year. And they are related to some calendar effects that one year the event could happen on a Monday and the next year it could be on a Tuesday or on a Sunday. So to deal with this effect, we created something called discrete interval moving seasonalities. The difference from other models is that it forms part of the main model. It is completely integrated as a new seasonality, but only when this spatial event appears. It has its own smoothing parameter and is added to the rest of the equations and must also be fit during the same process. You may notice all these discrete seasonalities squared in the blue dashed lines. The new proposal is, instead of using exponential smoothing to obtain these discrete seasonalities, will be used pattern sequence forecasting methods. How works this clustering algorithm? PSF is based on a clustering algorithm. We try the three k-means, k-means plus plus, and k-medoids methods to obtain patterns on clusters. On the left side, you see the data that has been normalized between 0 and 1 and put all together. What you see here is the holiday clustering. Although they seem to be different from the rest of the time series, they can be modeled as similar because they all share the same features. There are not big differences on using any of them. So in this work, finally, we decided to use the k-means plus plus. Using this clustering technique, we label all spatial events and cluster their effect. Using pattern sequence forecasting algorithm, windows of all these level clusters are sought, trying to find previous windows that match the same pattern. Then, collecting the information on all previous windows, an average of the next value is produced to predict the new value we want to obtain. What we did was just to integrate this algorithm in the calculation of the DIMS. You can see here this framework how has been done. The time series is used by the multiple seasonal whole vintage model, and the discrete seasonalities are produced using maybe the same method than before, but also using the pattern sequence forecasting. In this work, all of the discrete seasonalities have been obtained using PSF methods. When we work with all these methods together, we obtain the forecast. Then we applied this novelty to several electricity demand series obtained from nTSO. This is the European TSO regulator that provides this electricity demand series. You can see here on the right side we have demand for Czechia, France and Germany. France and Germany are on the same level, although the behavior is not the same, but Czechia has a different behavior. Due to that, we use these three time series. The results should be assessed. And the accuracy indicators that we used in the work was first the root of the mean square error that was used to feed the models. And to compare the forecast produced by the models, we use the mean average percentage error. In this work, we focus our efforts in the application to December 25th. This is because although multiple seasonal whole winters using discrete seasonalities worked really good for all these holidays and Fridays, for this day especially, the results were not accurate. Due to that, we were looking for another methodology that could improve results just for these days. Then we applied this new method to the time series to the demand to the electricity demand for Germany, France, and Czechia for the years that are mentioned in this table for 2012, 13, and 14. You may see on the third column that the regular method does not always provide good or accurate forecasts. Well, that was expected. This day is really special because it is not only that could be affected by Christmas Eve or Christmas Bridge, the day 26, but also, for instance, in France, the 26th is also a holiday, and depending on where these days lay during the week, every year has a different behavior of this series. Then we tried with the older method using whole winters and season and discrete seasonalities. You may see the results. They were improved, but not much. Finally, we applied this new methodology, and results are really promising. Maybe are not on the same level as we would like, but results have been improved. And then this is what we were looking for. To show you graphically the results, you can see here the plot of the forecast. This is for France, and you may see on the left side of the graph the observed values and the fit model, and at the right with the red line the forecast provided by the model and the real data that actually were occurred. You may see this model follows more or less the pattern, but the difference against the real values were not so big, and so we can say there was an accurate forecast. It is clear it could be improved, but we are on this way. For Germany that has a different behavior, you may see how the results are more accurate. So finally, we want to enumerate the conclusions. So the introduction of the pattern sequence forecasting used in the discrete seasonalities has improved the forecast for some special events. In this case, for December 25th, that was our objective. The mean average percentage error has decreased from high levels that were always over 10% to under this 10%. And so in the future works, what are we going to do is to introduce more artificial intelligence methods for this discrete seasonalities management. These are the credits for the pictures you have seen at the beginning, and thank you very much. We hope it has been interesting for you.